Hello, this is my submission for the machine learning model building end of course exercise for the combined cycle power prediction. Based on the data file that we had, several thousand rows, it's clear that it's structured data, not a lot of data, but enough. So I chose to use parametric algorithm, linear regression, due to the fact that it's a known form to the model. The input and output relationship is known, and also these kind of simple linear regression models learn well on limited data sets. A single linear regression is not enough. We would need multiple lines, and a multiple linear regression model is what I proposed. I did investigate other models, for example, ensemble models for higher accuracy, but I don't have the computing power for that as I'm using Excel. Next was to consider more advanced regression. I investigated random forest, for example, for even higher accuracy. But due to complexity, I stuck with simple multiple linear regression based on what I've just said. I compared the models using a validation, cross-validation set, using 5 different folds across the training data. I did split the data 80%, 20%, 80% was training, 20% was final test. So across that 80%, I did make 5 folds. You can see here fold 1, for example, there's 5 folds in there. What I did was to assess the model rather than using different algorithms. I used the same linear regression algorithm twice. So model A here, model B, and the way I decided to distinguish between them was model A only used 3 features, and model B used 4 features, and the criteria I was using was the accuracy of the prediction of the power output. So my target was the power output, and the inputs or features, let's say, of ambient temperature, exhaust vacuum, ambient pressure, relative humidity, were kept. But what I did was in model A, I only used 3 of those. I deleted ambient pressure. In model B, I added it back in. So essentially it's multiple linear regression in both models. Model A uses 1 less feature. Model B uses all 4 features available. I assumed having all 4 features available would increase the accuracy. That was the hypothesis I had. So I ran both models with 3 features and 4 features, and in the end, you can see here with the training data, model A with only 3 features, so that's with humidity removed, it was 3.88. Model 4 with it added back in, interestingly, the MAE was higher, which I wasn't expecting. I did some research on ChatGPT, and it said that is possible due to the nature of relative humidity and its influence on the other variables. Those other variables, especially temperature, have far more influence over the power output. So I decided to run with model A with only 3 features, not 4. I ran the same linear algorithm again, and the result was 3.89 MAE. And you can see here, if I go to the development model, the final test model here, as you can see, I repeated it with the test data, the 20% data that I initially isolated at the beginning of the exercise, and because it's model A with the relative humidity removed, you can see here my MAE of 3.88. So in the end, I've run 2 models. I've completed the exercise with the prediction with an error rate of 3.88.